In this video, we're going to take a look at making some measurement conversions. And we need to be able to make measurements conversions between imperial and imperial units, metric and metric units, and between imperial and metric units. So we're going to look at some different examples. Before we do that, it's always important to know that you have to have a relationship between the two units involved that you are converting from and to. And so here are some common ones in the imperial. This is English. I haven't usually heard it in that term. We're going to refer to this as imperial. All right. And then there's metric. Okay. So the imperial units are inches, feet, yards, broads, and miles. And so there are some equivalent amounts for each of those. And then in the metric system, it's based on powers of 10 or multiples of 10. You will always have a base unit involved, which relates to the type of measurement, whether it is a length or a mass or a volume. So in our case, generally length will be used, so the base unit will be meters. And then depending on how much larger or smaller the unit is than a meter, it will be a multiple of 10, actually a power of 10 higher or smaller. So 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, and so on for units that are larger, and 10 to the power of minus 1, 10 to the power of minus 2, and 10 to the power of minus 3, and so on for units that are smaller. So I have written some important conversions here. If you want to make a note of those, then I would suggest stop the video and write these down. So in order to get an idea of the size of a lot of these different units, it's a good idea to have something that you can think of that measures approximately that length. Like, for example, inches. 1 inch is about that far. Try to think of something that is 1 inch. And I would say, often a zipper pull on your winter coat. Okay, so a zipper pull is about 1 inch. A loonie is about 1 inch in diameter. Okay. There's some examples that measure approximately 1 inch. And then there's a foot. Okay, 1 foot is 12 of those inches. So try to think of something that is approximately a foot. A yard is 3 feet. So generally it's about the span of your arms out from hand to hand. And so on. So that's a good thing to keep in mind when you got to have a general sense of what it is. It's not something you'll use to measure, but at least to approximate. Moving on to metric. The metric system built on base units, and here are 3 common base units. Not all of them, but 3 of the common base units: liters, meters, and grams. We will mostly be working with meters, but I've put the others here as a couple of other examples. So if we need a unit that is smaller than a meter, and a meter is a little bit different from a yard, but very close to it, and about the span of your arms out from hand to hand. And a decimeter is 10 times smaller than a meter. So there are 10 decimeters in 1 meter. And notice, on our scale, if we go from meters to decimeters, we make 1 jump along the scale. That means the difference is 10 to the power of 1. Not a symbol. And from meters to centimeters, it is 2. So this will be 10 to the power of 2, or 100 times 100 centimeters in a meter. and 10 to the power of 3. There are 1,000 millimeters in 1 meter. So a millimeter is 1,000th times smaller than a meter. Going in the other direction, when we go from meters to decameters, a decameter is 10 times larger. So there are 10 meters in a decameter. The unit is 10 times larger, so in terms of the number of decameters to equal a meter, it will be 10 to the minus 1, because the number of decameters would be smaller than the number of meters. And going to hectometers, 10 to the minus 2 for the number of hectometers equal to the number of meters. And 1, 2, 3, 10 to the minus 3 for the number of kilometers equal to the number of meters. So notice I kind of covered that up, but below that I have multiply by a power of 10, right? Multiply by a power of 10 when you are moving this way. And that just means your number will get larger. And when you are moving the other direction on the scale, divide by a power of 10. That just means your number needs to get smaller, or you are multiplying by 10 to a negative power, which is the same as making the number smaller. All right, so the best thing to do would be to look at some examples. So we're going to look at a method that works for all conversions. You need to know the relationship between the two units involved, and then this method will work all the time. Now, I'm not saying that for every conversion you're going to need to go through this full process, but if you are unsure about whether you are to divide by a value or multiply by a value, then this method will solve that dilemma for you. So let me show you the method. Let's convert 75 inches into feet. Now, we know that there are 12 inches equal to 1 foot. So we want to see how many feet we can get in here. That means how many multiples of 12 are there in 75, and are there any left over? So let's see. Just the mathematical process is I'm going to take 75 inches and I want to convert it into feet. So mathematically, if we multiply by what is called a unit fraction. Now it's called a unit fraction because it's equal to 1. And remember with fractions, you put anything over itself. All right, x over x. These two values are equal to each other, then this is equal to 1, right? Well, if I put two values equal to each other in the numerator and the denominator, then it's a unit fraction. And so we already see that these two values here, these two values right here, 1 foot and 12 inches, are equal to each other. So let's put them in the unit fraction. Now I want to place them in a specific way because we want to convert from inches into feet. So we don't want inches anymore. We want to cancel the inches out of the mathematical equation. And right over here, inches is in the numerator. So in order to cancel inches from the numerator, I need to have inches in the denominator. So I will put my 12 inches down here. And it's equivalent to 1 foot, which we will put up here. This is a unit fraction because 1 foot is equal to 12 inches. And so all I'm doing is multiplying my 75 inches by 1, right? This is equivalent to 1. And so, but it will change the way it looks. We will cancel the inches. We'll be left with feet or foot. So 75 times 1, we multiply the fraction, 75 feet divided by 1 times 12 is 12. Well, we still need to do the division because 75 over 12 feet will be the number of feet. Well, does 12 go into 75 evenly? No. So 12 goes into 75.
6 times 12 is 72, and so there are 3 12s left over. 6 feet and 3 12s, 3 inches. So this is 6 feet, 3 inches. Because 3 inches out of 12, there are 12 inches in each foot. 3 of them are here. And there's the conversion. If you want to leave it as a decimal, this 3 12ths would reduce to 1/4 or 6.25 feet. Okay. Now, that was a fairly easy example because everybody would know, well, if I've got inches and I'm going to go to feet, I should divide by 12. But if you're unsure, then this logical way of setting up the unit fraction settles that, cancels the units, and leaves the ones that you want.
Here's another one to practice. So stop the video and give this one a try using the same process as above. I've given you the relationship between miles and yards. All right, so I'm converting 2.6 miles. I would like to use the relationship given in my unit fraction, and my goal is to cancel miles and leave it in yards. So therefore, the miles that is in the numerator here should get canceled with if I put 1 mile down here. And in the numerator, 1,760 yards. And double check that your units cancel. Remember that this is over 1. And let's multiply straight across. 2.6 times 1760. And that is 457.6. Yards are left. And in the denominator, 1 times 1, that's 1, so I don't need the denominator. Now let's take a look at an example that is metric to metric. So we're going to convert 256 centimeters into meters. And remember, over here we've got meters, and then we have decimeters, and then we have centimeters and millimeters on this side of the scale. And going this way, we need to multiply. Going this way, we need to divide. So I'm going from meters to centimeters. We're going from centimeters to meters. We're going from centimeters to meters, right? That means we're going to the left. The number of meters will be less than the number of centimeters because meters are larger, so we don't need as many of them. So we will divide by 10. So we're going to divide by 10 to the power 2, which is the same as multiply by 10 to the power of negative 2. So that's why you see a negative sometimes for that direction. It's the same. We change the operation to division, it becomes a power 2. So right now, this decimal sits right here. We're dividing by 10 to the power 2, or divide by 100. When you divide by powers of 10, you just move the decimal that number of places. So this is 1, 2. So this will become 2.56 meters. Let's do another one. Let's look at, let's still keep our unit there. Okay. Let's make up a number. How about 6,325 millimeters? We want to go to meters. All right. Take this away. I'm converting from millimeters to meters. Millimeters are very small, 1,000 times larger than a meter. And so I'm going 1, 2, 3 moves along the scale. We're going to the right, so we need to divide. I'm going to divide by 10 to the power of 3, which is the same as multiply by 10 to the minus 3. So dividing means our decimal moves to the left. So we'll go 3 places. 1, 2, 3. So the answer is equal to 6.325 meters. All right, now I'd like to look at an area unit, meters squared to centimeters squared. So the power of 2 means that there's a conversion between meters and centimeters, but done twice. And so let's take a look at why. If I have a square here, and this square measures 4 meters by 4 meters. The area of this square is 4 times 4 meters times meters, 16 meters squared. Okay? Now, convert each of those lengths into centimeters so that we can get the area into centimeters squared. Well, 4 meters, if I convert meters to centimeters, we go 1, 2, and we're going to the right, so we will multiply by 10 to the 2. And so this is equivalent to, not 4, but multiply by 100, 400 centimeters. And this is equivalent to 400 centimeters. So the area is actually 160,000 centimeters squared. Now, you won't want to just convert by multiplying by, you don't just take your 16 and multiply by 10 to the 2. What we have to do is take our 16 and multiply by 10 to the 2, 1, 2, for one dimension, and for the other dimension, 1, 2. So 0, 0, 0, 0. Then we get our 160,000 centimeters squared. Okay? If you want to use the unit fraction method, 16 meters squared. In the unit fraction, you can put the relationship between centimeters and meters. 100 centimeters equals 1 meter. So I will put my 1 meter in the denominator so that it will cancel with the meter up here. And my 100 centimeters goes up here. But notice that this is squared and these are not yet. We need to square them all. And remember, with exponents, that power of 2 has to be on every factor inside the brackets, on the numerical part there, on the unit, on the numerical part there, and on the unit. So it will actually become looking like 16 meters squared multiplied by the unit fraction, that is 100 squared is 10,000 centimeters squared. Got to square everything. 1 squared, well, that's 1, and meter squared is meter squared. Now we have equivalent units to cancel, and our 16 gets multiplied by 10,000, which is 160,000 centimeters squared. Okay, I'm just writing the decimal here because I want you to see exactly where it ends up. All right, lastly, let's take a look at a measurement that is from metric to imperial. It will work the same way as if we are doing imperial back to metric. And I'm going to do a conversion with 71 inches, converting them into centimeters, with the known fact that 1 inch is equal to 2.54 centimeters. We'll use that relationship. Again, I'm going to use the unit fraction method. So think ahead about where you will place inches and centimeters in your unit fraction, the numerator and the denominator. We're going to convert 71 inches. There's your unit fraction. Set it up. You want to cancel inches. Giving you a pause to decide where it goes, numerator or denominator. Great. 1 inch down here, 2.54 centimeters here. And that tells us we're going to multiply by 2.54 rather than divide. And so there's my canceling. We've lost the inches, and I will multiply 71 by 2.54. And it's 180.34. And it's now in centimeters. Okay, so I'm not saying that this is required method for every time you do a conversion. The ones that you're doing often, you're just going to get to know and you won't have to write it out. This is a method for when you're not sure. It's logical, it makes sense. You can set it up to cancel units, and that's very helpful. Okay, well, thanks for watching. See you in the next video.